Now, that was a little bit easy because we knew that eventually we were going to get side, 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 or side, angle, side. But you're not always going to know which one you're going to get until you start trying to prove it, okay? For example, now we're going to combine them, okay? We don't know what it is until we start talking about it, okay? So our directions say, state whether the triangles can be proven congruent, if possible, by side, 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 or side, angle, side. And we're to include a congruency statement for all congruent triangles. So let's start with number 1. So as you can see, it's given me some information by the marks on the triangle, okay? So what is the first thing that you see is congruent? Side QY is congruent to side KC, okay? So QY, oh, I don't know why I'm writing that. So QY is congruent to KC, okay? Then we have this angle is congruent to angle K, right? Angle Y is congruent to angle K, and we know that because of the marks that they put on there. The last thing that they tell me is congruent is line TY to line KP, okay? So is this side, 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 angle, side, or neither? You should say it's side, angle, side, because we have one side, then we have an angle, and we have a side. Okay, so it's SAS. And then if we were to write a congruency statement for that one, it would be triangle QYT is congruent to triangle, well, which one is congruent to Q? It's C, because they're both obtuse angles, right? And then which one's congruent to Y? K. And then last, angle T is congruent to angle P. So that's my congruency statement, okay? Now let's look at number 2. So it gives us that line AD is congruent to line BC. And it also tells us the line AB is congruent to DC, but then gives us nothing else, okay? So we kind of look at it. So again, we have 2 triangles and they share one side, right? So therefore, that side is congruent by the reflexive property. So how many pairs of sides do I have are congruent? 3. So it's side, side, side congruency. So if I were to write a congruency statement, it would be triangle, let's see here. Let's do ACD is congruent. Well, angle A is congruent to angle C. Angle C is congruent to angle A. And angle D is congruent to angle B. Okay. Now number 3. Now, if you look at the diagram, we kind of have 3 triangles, okay? But this is our like actual triangles. This one is one triangle, triangle JMK, and then triangle LKM are the ones we're looking at, okay? So they tell us that line JM is congruent to line LK, okay? Let's see what else they tell us is congruent. They also tell us that angle M is congruent to angle K. And then they tell us nothing else, right? So we gotta kind of use our brains a little bit. Well, if you saw that highlighted, I highlighted line MK twice because they both share line MK. And again, we know if 2 triangles share one side, then the side is congruent to itself by reflexive property. So what is this? Is it side, 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 angle, side, or neither? You should be saying side, angle, side, because this is a side, this is an angle, and this is another side. Okay, same thing for over here. And if we were to write a congruency statement, let's start with angle J, triangle JMK is congruent. Well, angle J is congruent to angle L. and then angle M is congruent to angle K, and then angle K is congruent to angle M. So that's my congruency statement for that one. Now let's look at number 4, okay? What do you think it will be? Most of you guys will say it's side, angle, side. Probably 2 of you will say it's side, 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 but let's look at it, okay? It tells me that line SU is congruent to line UT. It then tells me that angle U, ooh, that was supposed to be a different color. Angle U is congruent to angle U. And then it tells me that SV is congruent to line TW. Now you gotta look very careful here, okay? It seems like side, angle, side because we have 2 pairs of congruent sides and then 1 angle. But again, the order matters, okay? Is angle U in between the 2 2 lines that are congruent? No, okay? This one is side, side, angle, which we know is bad, okay? Because backwards, it's a really bad word. So we don't allow that in school, so we don't allow side, side, angle in geometry. Okay, so really, this is not congruent, okay? Because it wasn't side, 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 and wasn't SSA, okay? Again, location matters. So I'll do 5, 6, 7, and 8 by yourself. Pause this video, and then I will talk about it in a second. Alright, you should have worked through these on your own. Hopefully you did. So number 5 is side, 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 because CE is congruent to ED. CF is congruent to FD. And then because the 2 triangles share EF, it is congruent to itself by reflexive property. So you have 3 pairs of congruent sides. An example of a congruency statement could have been triangle CEF is congruent to triangle CEF, okay? And be careful with this one, this congruency statement, okay? Does angle E even look like angle F? No, so you can't do the opposite like they did here, okay? Angle E here is a right triangle, and angle F is clearly a acute triangle, okay? So number 6 was side, angle, side, because JD was congruent to ME, DA was congruent to AE, and this is where a lot of people get mixed up. So yes, angle A is congruent to angle A because they're vertical angles, but we did that, then we have side, side, angle, okay, which is, again, very bad, right? Remember that these symbols mean the lines are parallel, okay? Which means we get to use a angle relationship, okay? So really, with those 2 lines being congruent, with these lines being congruent, what angle do we want to find is congruent? Angle D and angle E, because it is an included angle, okay? It's in between the 2 sides, okay? So, again, we have our parallel lines. And we have that this is a transversal, okay? So this is angle D, and this is angle E. Now, how are those angles congruent? Are they on the same side of the transversal? No. They're on opposite sides of the transversal, so they are alternate interior angles, which is why they are congruent, okay? So angle D is congruent to angle E, therefore giving it side, angle, side. And one of the congruency statements you could have written was triangle JDA is congruent to triangle MEA, okay? But again, there's multiple options there. Now let's go to 7. Now, number 7, again, you possibly could have picked SAS, but if you did, you were incorrect because this is not congruent. I'm just going to write the congruent symbol. So it's not congruent, okay? Because yes, PQ is congruent to TU, and PR is congruent to SU, and angle Q is congruent to angle T, but those angles are not included, okay? They are not between the two sides, okay? Now, if it was angle P is congruent to angle U, yes, that would be SAS. It would be side, angle, side, but it wasn't, okay? And since the triangles are not congruent, then you cannot write a congruency statement. Number 8 was SAS, because BC is congruent to DC, AC is congruent to EC, and then we know that angle C is congruent to angle C due to vertical angles, okay? And we wanted angle C to be congruent to angle C because it's in between the two lines. So an example of a congruency statement for that one is triangle ABC is congruent to triangle EDC, okay? So now let's start writing some truth tables without knowing whether it's going to be SSS or SAS, okay? Again, your first statement is the first thing that you're given, okay? So line AB is congruent to line CD, and your first reason will always be that it's given. And then we go mark that onto our diagram. So line AB is congruent to line CD. We are then given that line AB is parallel to line CD. Okay, so line AB is parallel to line CD. And why? Because it is given. Okay. Now, for this next statement, you can go two ways. Okay. You can go what is given to you, or you can talk about what happens because the lines are parallel. But for right now, for the sake of this video, I'm going to go with what is given to me. Okay, so tell me that D is the midpoint of line BE. And why? Because it is given. Okay, now we immediately know that because line D is a midpoint, what two lines are congruent? It splits up line BE, right? So BD is congruent to DE. Okay, and that will be our next statement. So BD is congruent to line DE. And why? Well, it happened because we had a midpoint, right? So therefore, it's because the definition of midpoint. Okay. Now let's go back to this statement right here, okay? Let's talk about the parallel lines, and because we have parallel lines, we know we're eventually going to get a relationship, right? So line AB is parallel to line CD, and that's given, okay? Which means AD is a transversal and BE is a transversal. But really, we're just going to worry about the line BE is a transversal because we either want to get side, side, side or side, angle, side. Right now, it's looking like we're going to get side, angle, side. So we want that B is congruent to D, okay, because it's in between these two lines. So this is a transversal. And these are my two parallel lines. Okay. So if we look, angle B and angle D, are they on the same side of the transversal or on opposite sides? They are on the same sides of the transversal, okay? And if we go back to our reference sheet, what are our two options? Alternate, interior, or corresponding? Well, alternate means they're on opposite sides of the transversal. So if you didn't remember, you should. These are corresponding angles, okay? So therefore, we'll write the angle B is congruent to angle D because they are corresponding angles, okay? You always use previous knowledge in geometry. So that's it. I got parallel line here. I mean, not parallel, congruent lines here. I got that angles are congruent, and then that these sides are congruent. So triangle ABD is congruent to triangle CDE. Why? Because of side, angle, side. All right, so let's continue. Let's flip the page. Now, if you thought this one was a little bit hard, this one's a little bit easier, okay? It's actually a lot easier, okay? So what are we given? Let's start with what we're given. We're given that line KM is congruent to line NM, okay? And what's the reason? It's given. They told us, so we believe it. So now that I wrote that down, we go mark it on a graph, okay? So KM is congruent to line NM. Well, we're given another thing. They tell us that line LK is congruent to line LN. The reason being that they told us it was given. Then we go mark that on our graph, okay? Now again, this is two triangles, right? It's triangle LKM and it's triangle LNM, okay? But they both share line LM. And we know that they both share a line. The line is congruent to itself. And why do we know that? The reflexive property. Okay. So I now have 3 pairs of congruent sides. Therefore, I just proved that triangle LKM is congruent to triangle LNM by side, side, side. Also, I don't know if I mentioned this before, but your last statement in the box will always be what you're trying to prove right here, okay? Let's talk about number 11. So we're given that line AD is congruent to line AB. Okay, it's already marked for us on our graph, but I like to go mark it twice because I'm an overachiever. Not really. And then we're given that line AC bisects angle DAB. Okay, so this is DAB, this is the angle, and gets split in half, so 2 congruent sides, by line AC. Okay, so that means that angle DAC is now congruent to BAC. Okay, so these angles are congruent to each other. Oop, I didn't write. It was given. That's my bad. Because these were given. And notice again, I had that line AC bisects angle DAB because it was given. And from that, I was able to tell that angle DAC is congruent to BAC. So that's my next statement, okay, to help prove that's congruent. So angle DAC is congruent to angle BAC. And why? Again, because of definition of angle bisector. Because I know what an angle bisector is. Okay? And sadly, we're not given anything else from like what they just told me. But let's look at our diagram, right? It's 2 triangles, and they both share a side, which is side AC. And as we've said many, many times, a side is congruent to itself by the reflexive property. Okay? So this is congruent. So we have a pair of sides are congruent to each other. Then we have a pair of angles are congruent to each other. Then we have a side is congruent to a side. So therefore, triangle ADC is congruent to triangle ABC by side, angle, side. Okay? Now, if you want, you can try number 12, pause the video, and then I'll go over it. Well, I won't really go over it. I'll just tell you the answer. All right, so if you stuck around, good for you for wanting to learn. So, line JM is congruent to line NM because it's given. They told me that, so I went and marked it right here. Then they told me that L is the midpoint of line JN, so write that down. The reason why it was given. And I went and drew a little point at L because it was midpoint. Now, from midpoint, I know that splits line JN into two congruent segments. So JL was congruent to LN. And that was my next statement. And that was because definition of midpoint. Okay? And then it didn't really give us anything else, and I can't go off anything else. So I had to look at my diagram. Okay? Well, I noticed that triangle JLM and triangle NLM both share one side together, which is line LM. So line LM is congruent to line LM due to reflexive property, okay? That's when a side is congruent to itself. And since now I have three pairs of congruent sides, triangle JLM is congruent to triangle NLM due to side, side, side. And that's it. All right, so if you stuck around, good for you for wanting to learn. So, line JM is congruent to line NM because it's given. They told me that, so I went and marked it right here. Then they told me that L is the midpoint of line JN, so write that down. The reason why it was given. And I went and drew a little point at L because it was midpoint. Now, from midpoint, I know that splits line JN into two congruent segments. So JL was congruent to LN. And that was my next statement. And that was because definition of midpoint. Okay? And then it didn't really give us anything else, and I can't go off anything else. So I had to look at my diagram. Okay? Well, I noticed that triangle JLM and triangle NLM both share one side together, which is line LM. So line LM is congruent to line LM due to reflexive property, okay? That's when a side is congruent to itself. And since now I have three pairs of congruent sides, triangle JLM is congruent to triangle NLM due to side, side, side. And that's it.